Okay, so hello, my name is Michal. I work at NXP Semiconductors in the SDK middleware team as software engineer. And today I would like to introduce the project we are currently working on. It's a new multimedia framework called MediaPipe library, or libMP for short. First, I will talk about the motivation and context behind the project. Then I will mention some existing frameworks and introduce what libMP actually is. After that, we can take a look on how developers can use public APIs in their applications. And I will also explain the difference between properties and capabilities. Then I will talk about the current state of the project and our future plans. At the end, I will show you a live demo of simple pipeline running on Zephyr OS, and finally there will be time for your questions. So as you have probably noticed, multimedia is becoming more and more important in embedded systems. We can see it everywhere in smart cameras, voice assistants, car infotainment systems, and even industrial touchscreens. And these kind of devices need to handle very complex tasks like signal processing, audio streaming, video streaming, and even running AI and ML models. And as you can imagine, doing all that from scratch would be extremely difficult and time-consuming. So that's also why developers often rely on multimedia frameworks, because they provide you ready-made building blocks, and these blocks make development easier and faster. One of the available frameworks we have is GStreamer. For those who are not familiar with it, GStreamer is an open source powerful tool used to build multimedia applications. It works by connecting small components called plugins into media processing pipeline, and each plugin handles specific tasks such as reading media file, decoding audio, decoding video, or sending output to the screen or to the speakers. GStreamer is a great choice for MPUs, especially when running Linux, because in this environment we have a lot of or enough system resources for support its complexity. But GStreamer is not suitable for MCUs, which are much more limited in performance and memory. So, are there any frameworks for MCUs? Yes, there are. For example, NXP provides Maestro Audio Framework and Media Processing Pipeline. However, these frameworks don't support full multimedia pipelines like GStreamer does. And in addition, both frameworks currently run only fully on free RTOS. So at the moment, we don't have available any framework running on Zephyr OS. That's also why we decided to create a new multimedia framework called MediaPipe library. Right from the start, I would like to say that our goal was not to reinvent the wheel, but rather build on proven ideas and reuse the best parts of existing frameworks, especially GStreamer. You can think of libMP as a light version of GStreamer, that is optimized for MCUs because it follows many of implementation concepts, such as similar naming conventions, enums, macros, and even inheritance-based architecture. And thanks to this, libMP is modular, scalable, and easy to maintain. Another important point I would like to mention is that the framework is currently designed to run on Zephyr OS, and we plan to integrate it as internal Zephyr library. So Therefore, we believe it will make it easier to adopt and maintain the framework within Zephyr-based projects. On this slide, you can see an example of application code that developer may write for audio pipeline, for simple audio pipeline. In this case, we have digital microphone as audio source, gain element in the middle, and audio codec as audio sink. From code snippet, you can see that the flow is quite straightforward. At the beginning, we initialize the MediaPipe library, or simply libMP. Then we create required elements and set them to their default state. After that, we can adjust the properties of selected elements if needed. For example, here we are setting gain value for gain element, but this is just for demonstration. And next, we can create an empty pipeline, add elements to it, link them together, and once all elements are linked in pipeline, the pipeline is ready to run. We just need to set its state to playing, and audio processing starts. One of the key advantages of libMP is that its public API is stable and well abstracted. It means that developer don't need to worry about internal changes because your code stays same even as core of libMP evolves. You may also notice that we didn't set any audio-specific parameters like sample rate, bit width, or number of channels. And you may be wondering how is it possible that pipeline works without them. And the answer lies in capability negotiation mechanism. Because in addition to properties, each element has also its own capabilities, and the difference between properties and capabilities is that properties are configurable attributes that allows application to configure the behavior and settings of these elements. For example, we can set gain value for gain element, but not for audio sink or audio source. We can set volume value for audio sink element, but not for gain or audio source. And we can set brightness or contrast for camera, for example, but not for transform element, which resize the picture. So it means that each element has its own specific properties, but capabilities, on the other hand, describe supported media format and formats of data which element can process. For example, it describes whether the element can process audio data in raw format or in compressed format like MP3. It also describes which sample rates, bit widths, or number of channel can element handle. So these capabilities are used to ensure the compatibility between elements in the pipeline. And this compatibility is negotiated at the beginning, automatically at the beginning of the stream using capability negotiation mechanism. This means that developer don't need to set these parameters manually, but if developer wants to run on, for example, 48 kilohertz sample rate, the application allows you to force the preferred format using capability filter element, which influences process of negotiation. So, so far we have talked about the technical side of libMP, and now I would like to share current state of the project and our future plans. We have already implemented basic elements like source, sink, transform, and pipeline. We also implemented simple audio and video plugins. Capability negotiation mechanism also works. So at the moment, we are able to build a very simple audio and video pipeline. And in the future, we would like to support buffer negotiation mechanism, capability filter element, and also multi-core support, because sometimes you want to run different parts of pipeline on different cores. For example, control logic on ARM, signal processing on DSP, and AI models on neural subsystem. What about libMP and Zephyr mainline? So libMP is still under internal development, so it's not yet part of official Zephyr mainline. However, we are currently preparing an RFC to start process of integration. So we believe the libMP will can become a valuable tool, not only for NXP but also for wider developer community, which works with microcontrollers and multimedia applications. So now it's time for live demo. I have prepared this setup. Here is RT1170 EVKB board from NXP. There is also camera and display. Everything is powered up by power bank, so it's fully portable. And in the MCU, there is running a very simple pipeline with video source element, transform element, and video sync element. And the transform element is used just for resizing a picture before it's shown on the display. So now I can send the hardware to you, and in meantime you may ask questions if you have.
I have a question. First one is, so can be then used on non-NXP devices, let's say.
Yes.
Let's say. And second one, I think I saw some video, there was some guy creating some library for camera pipelines. I'm not sure if this is like maybe...
You mean video for Zephyr, subsystem in Zephyr?
Maybe, yeah.
It's my colleague.
And I remember exactly. I know that was it was part of this on the YouTube channel of the Zephyr, but I don't remember the name of the project. But I know that was a similar concept, but focused on image processing from camera.
My colleague works on video for Zephyr subsystem, and it is also used by libMP. So if you don't have any other questions, that's all from my side. I will pick up hardware later.